Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat? If I'm audible, then we would start right away. Just let me turn on my preview screen. Hi and welcome to Geeks for Geeks. Yeah. Um. Okay. So let's start with yesterday's problem of the day. That is rotten oranges. Okay. So this problem appeared in Acolyte, Amazon, and 5 more companies. This problem involves graph, matrix, and BFS. Okay, and this problem has a success percentage of 51%. This is a medium level problem. Now let us move to the problem statement. We are given a grid of dimension n into m, where each cell in the grid can have 0, 1 and 2. So what is n into m? Suppose we have something like 2 cross 3 matrix. Okay, so this would be 2 rows and 3 columns. Okay, and there would be columns, 3 columns, and that would be filled with either 0, 1 or 2. Now let us understand what are the meaning of those. 0 means it is an empty cell, and 1 means it is a fresh orange, and 2 means it is a rotten orange. Okay, so let me just remove this. Yeah, so we have to determine what is the minimum time required to rot all oranges. A rotten orange at index I and j can rot other fresh oranges at the index I minus 1 and j, I plus 1 j, I minus 1 and ij plus 1. So what can be done is, suppose I am at the index this one and there are 4 indexes surrounding me. So this can be the particular matrix. So suppose I am at this position, then what all positions I can visit are, I can visit this position, I can visit this position, I can visit this position, and I can visit this position. So these all positions I can visit in a time frame of 1 second. Fair enough. Let us move forward. Okay, just let me refresh my screen so that if anyone is texting something, yeah, fair enough, we don't have any text. Okay, so let us then draw the grid and let us see how we can rot other oranges. Okay, so suppose we have 0, 1 and 2. Again 0, 1 and 2. We have 2, 1, 1. So first this rotten oranges would start rotting at 1 unit time. So this rotten orange would rot this fresh orange, and this is already rotten, so it won't be able to appear, and these two places are not valid, they are not there, so it won't happen. In the same time, this can also rot in this position, and this can also rot at this position. Fair enough. And in the same time only, this rotten orange would also start its action, that it would start rotting this orange, and there it is empty, so it won't happen. So after 1 second only, we have rotten all the fresh oranges. Okay, no fresh oranges is remaining, so there is no point in moving forward. Okay, so we can say the answer for this is 1 second. Okay, so how can we solve this? To solve this is a simple thing. So the brute force thing can be, we need to see what is the minimum time to reach from here to here with 4 directions allowed. So minimum time means shortest path. Okay, shortest path. When we talk about shortest path, and each time it would have 1 unit only. It doesn't happen that in the first hour it would have 1 unit time in unit time, and the second hour it would take 2 unit time. It won't happen like this. So uniform time. Okay, uniform time. So is this akin to something? these two conditions are akin to something or not. First is the constraint that it is the shortest path. Second is the constraint that it is a uniform time. Okay, so we can think about something like BFS. It is a direct solution because it is the shortest path algorithm with uniform weights. Okay, so we can use that. So now thinking about BFS, what can be done is, we can, suppose we have something like this. So we have we have something like this, and suppose the rotten oranges are at this position, and suppose at this position and this position. Now the fresh oranges are suppose at this position, this position, this position, this position, and this position. So what we can do is, we can start rottening the orange one by one. Suppose this orange would take 1 unit time to reach here and 2 unit time to reach here. Okay, so suppose let us mark this 1, let us mark this 2. This rotten orange, this, remember this, and this would take 1 unit time to reach here, 2 unit time to reach here. We can do that. Now we would just keep as it is. Okay, we would just talk about these two, and then for this we can do is, we can come from this path or from this path, whatever is same for you. Okay, so 1 2 3, 2 plus 1 is equals to 3 position. Fair enough. So we, from this position, from this source, okay, from this source, let me encircle it. Okay, from this source I can reach all this position in these all times. Fair enough. And this can be found out by what? This can be found out by doing BFS. Okay, and then how BFS? We would first insert this I and j, that is 0 0, and then we would keep moving in the fourth direction if it is present in the matrix, and then we would see in how many unit time we can reach there. Fair enough. Now what we would do is, to solve this using simple BFS is, we would again come from this position. From this position I can reach to this position in 1 unit time, and this position in 2 unit time, and I can reach this position in 1 and this position in 2. So you can see everything is same, but instead of reaching this point in 3 unit time, I am able to reach in 1 unit time. So I would remove this and say that 1 unit time is required, because every orange would start taking it effect at the same time. मतलब बहुत सारे जो ऑरेंज है वो बहुत सारे जो ऑरेंजेस है या बहुत सारे जो ऑरेंजेस है वो एक साथ सड़ना शुरू करेंगे. सो वो एक साथ अपना इफेक्ट दिखाएंगे. तो एक साथ अगर इफेक्ट दिखाएंगे तो जो फ्रेश ऑरेंज पे जो पहला पहुंच गया वो तो उसको सड़ा दिया ना. देयर इज नो पॉइंट दैट वो बाद दूर वाला ऑरेंज जाके उसको सड़ाएगा. अगर सामने वाला ऑरेंज उसको पहले ही सड़ा देता है तो दूर वाला ऑरेंज आते आते बहुत लेट हो चुका होगा. दैट इज द होल थिंग. सो व्हाट वी कैन डू इज अप्लाई BFS from each rotten orange. Apply BFS from each rotten orange. Then we can start relaxing each positions. Suppose we are done till this point. We are done till this point. So what would be the time complexity? BFS has a linear time complexity. So to do a one round of BFS, we need n cross m, because there are n cross m to visit. So 1 into n cross m. Fair enough. Now the second is that suppose we have x number of rotten oranges. So x into n into m. This would be the time complexity. Fair enough. Can we do better than this? This seems to be the first solution that you would give to your interviewer, it might be the case that he would be impressed with this, but it might also be the case that he wants you to optimize more on this. How can you do this? Okay, so this is a very famous idea that whenever there are 3-4 points there and you want to reach to a shortest point, okay, reach to a shortest point from multiple sources and each point has a constant speed, then we use something known as multi-source. Okay, this is not intuitive, this is just a fact that whenever there are multiple sources and they all have the same speed and they try to visit each all, then we should use multi-source. There is no intuition in this. Okay, now talking about this, how we would do it. Let's see the BFS solution. Okay, so talking about the BFS solution, what we would do is we would implement a queue of what? A queue of integer, okay, integer who would contain the distance, and a pair which would be the coordinate. This is how we would do, and then we would insert the source. So q dot push, suppose the initial first source is 0 0, okay, so we would insert this with a distance 0. Okay, so q dot push operation, okay, then 0 distance with 0 comma 0, okay, x and y. Fair enough. Now we would do the same BFS while q is not empty. Okay, q empty is equals to false. Fair enough. Now we would use this body that whatever the neighbors, first we would keep the q dot top, then the neighbors would have a distance of +1, whatever we normally do. I'm only interested in this part. Okay, so this is the normal, that we would take out the top, pop it from the queue, and then we would assign each other neighbors with a distance +1. If it is better than the previous distance, we would update it, hence we would leave it unchanged. So that is done. So till this point if it is clear or not. Anyone wants any explanation over anything, I would tell you this. Okay, so let us recapitulate what have we done. Okay, first we had many rotten oranges, okay, which was rottening other oranges in a same unit time, and we can traverse in 4 direction. Okay, we needed to find out the shortest path with uniform time. So we thought about BFS because it is a shortest path algorithm with uniform, okay, with uniform edges. Okay, so we first applied BFS from each point, and whichever is best from any point, we would take it as the answer. Fair enough. Okay, then we would do what? We would take the maximum of whatever it is, because अगर 5-6 ऑरेंजेस है और हमें मिनिमम टाइम बताना है, तो जिस ऑरेंज को सड़ाने में सबसे ज़्यादा टाइम लगा वही हो गया ना सबको सड़ाने का टाइम. ओके, मैं बताता हूँ. सपोज आई हैव 4 oranges like this, okay, and the task and the minimum time to rot this oranges is 5 minutes, and the minimum time is 2 minutes, and the minimum time to rot this orange is 1 minute. So to rot all the oranges, 5 minutes is the minimum, because in 5 minutes all these oranges would get rotten. Fair enough. So as the view count is very less, I would quickly recapitulate and then I would move forward instead of waiting for your reply. Okay, then what we did was we started the BFS from each point. Then what we did was I wrote the code of it, and then we talked about the idea that we can do multi-source BFS. How to do that? That is a complete different scenario, but just the technical term was introduced to you. Fair enough. Now this q.empty is false. At the q.empty is false, we would do the BFS as told. Now we just need a simple edit and this would be converted to multi-source BFS. To do that, let me first remove this. It is removed. Now let me copy this and let me take it down. Okay, and we would add some few 1 or 2 lines that would make this multi-source BFS, and then I would explain it how it works. Okay, then I would write something in comments that insert all sources. Insert all sources. Then what we do is we insert all the sources that are there in the queue itself. Suppose the sources are 1, 2, 3, 1 and then 4, 5. Whatever are the sources, we would loop over them. We would run a for loop auto e dash whatever the loops we have stored. Suppose it is answer. So we would insert them in the queue with distance 0, because sources have a distance 0. 0 and e dot ff with e dot ss. Fair enough. We would insert all the sources and then we would perform the BFS as we were doing, and you would get the minimum distance in single iteration. You don't need to put all the edges. Now the point comes how this is working. To see how this is working, I would tell you first this. Suppose from this point, from this point, from this point and from this point, we went one direction here, one direction here, because these two are only allowed, and one direction here, one direction here. Okay, 2 direction allowed, 3 directions here and 4th direction here. So we would travel in all the direction at the same place. Okay, so ये हो गया कि हर एक पॉइंट से अगर हम लोग सारे को सोर्स करके उसमें डाल देते हैं तो ये सारे पॉइंट से प्रोपागेट होने लगेगा एट द सेम टाइम, बिकॉज ब्रेथ फर्स्ट सर्च की यही खूबी है कि फर्स्ट वी विजिट द पेरेंट, then we visit the children. So visit the parent first. So we would first visit these sources. So these all sources would be visited first. Then their children would be visited second. And this thing would be visited at next. Okay. Suppose I visited this, I visited this, I visited this, I visited this. First these all would be visited of each source. Then the neighbors of this would be again visited, whatever be it is. Fair enough. Now we use 2-3 things to implement this. What are the 2 things? I would be explaining you. So it is a general method that we do is we build a dx dy array. You can do it or rather skip it, whatever is fine with you. But if you want to learn a fast implementation with clean code, then this can be done. Okay, what I am doing is I have initialized with -1 0 and then 1 0 0 and -1 0 and 1. So basically what I am doing is, suppose we have I and j. If we first add this part, this would become I -1 and this j would remain the same because it is 0, and then the next would be I plus 1 and j. Fair enough. And the next one would be I only and j minus 1. Fair enough. And the next one would be I and j plus 1. So you can see that this 2 arrays are facilitating our visiting to all 4 directions. Fair enough. Now what is this valid thing? Okay, so when we were talking about the oranges, we were going in 4 directions of each orange. This direction, this direction, this direction, this direction. But to go in that direction, that place must be present, na? Suppose I can visit 5 kilometers, I can visit in left, right, here and there. But my mom told me to not move in the left direction. So if I'm not allowed to move in the left direction, that even if I have that capability to move in the left direction, I won't be allowed to do that. ओके, तो सपोज मेरी मम्मी ने ये कहा कि आप लेफ्ट मत देखना. ओके, फेयर इनफ. बट मैं तो चारों तरफ देख सकता हूँ. तो अगर मेरे पास पावर हो कि मैं चारों तरफ जा सकता हूँ इस ऑरेंजेस के पर्सपेक्टिव में, बट अगर वो अलाउड ना हो तो हम नहीं कर सकते, मतलब वो पर्टिकुलर कोऑर्डिनेट रहना भी तो चाहिए। नाउ लेट मी गिव यू एग्जांपल। सपोज वी आर एट दिस पोजीशन, सो इन दिस पोजीशन I can visit in this direction, I can visit in this direction, but this and this are not present only. So this moving in this direction would be useless and time taking and index out of bound, because these all indexes are not present only. So what I am doing is, if I is less than 0, or if I is greater than equal to n, or j is less than 0, j is greater than m. So we are just checking if it is within the boundary or not. If it is not within the boundary, I would return false, else I would return true. Fair enough. Now let us move forward to the code base. First what I did was, I like to write n is equals to a dot size and m is equals to ai dot size. Fair enough. Then we are making a visited array of n and m, so that we know which all are visited and which all are not visited. That we do in basic BFS. And in distance array, okay, we are storing the distance of each one, and we are marking each one as -1. Why we are marking? We would see to it. First we would mark that. Okay, because distance can never be negative, so this won't interfere with our answer. And visited array, we are making everything false, that everything is not visited at the present time. And then what we are doing is, we are marking the distance as -1, and if a-2 is equals to, suppose it is a rotten orange, then we are inserting the coordinates with the distance as 0, and we are marking it visited, because source तो हम लोग ने visit कर दिया ना, जो क्यू के अंदर गया वो visit हो गया है. That's the main thing. So समझ आया? First सारे को unvisited mark कर दिए हैं, और हम लोग distance को 0 रख रहे हैं initially, और सारे को अंदर दे दिए, और distance को -1 रख रहे हैं ताकि बाद में वो हमें काम आ सके. ओके, एंड माइनस डिस्टेंस कभी, नेगेटिव डिस्टेंस कभी हमें आंसर में कंट्रीब्यूट करेगा नहीं, सो हमें बॉदर होने की जरूरत है नहीं. ओके, लेट अस मूव फॉरवर्ड विद दिस. व्हाइल द क्यू इज नॉट एम्प्टी, फर्स्ट वी वुड टेक आउट द फ्रंट, एंड देन वी वुड रिमूव द फ्रंट, एंड देन वी आर चेकिंग if, and we are doing what, is equals to 0, less than 4 and I plus plus. We are basically iterating over these values like I showed you. Okay, so we are basically iterating over these values. So dxi plus dyi, if it is valid, first वो valid होना चाहिए. Okay, फिर वो unvisited होना चाहिए. Okay, and वो fresh orange होना चाहिए. Okay, so now I would tell you, suppose this is a rotten orange, fresh orange क्यों होना चाहिए? Okay, so suppose this, the array looks like this, might be the case, array would might look like this, and this is a rotten orange and this is a fresh orange, but here the place is empty. Okay, the empty, so this rotten orange is coming to this place but it is empty. So ये rotten orange, ये जो सड़ा हुआ orange है, वो empty place को तो सड़ा नहीं सकता है ना, कैसे कन्वर्ट करेगा, वो तो खाली जगह है. सो ये यहां तक पहुंच ही नहीं पाएगा. अगर वो यहां तक नहीं पहुंच पाएगा तो इसे कभी सड़ा नहीं पाएगा. ओके, सो रॉटन ऑरेंजेस के चारों तरफ जो फ्रेश ऑरेंज है, हम लोग उसे टारगेट करेंगे. फेयर एनफ. सो इट शुड बी अ फ्रेश ऑरेंज. मतलब वो ऑरेंज अनविजिटेड होना चाहिए और फ्रेश ऑरेंज होना चाहिए. एंड देन व्हाट वी आर डूइंग इज, if it is that case, then we are first visiting it, and then we are visiting the neighbors with a distance +1, and then distance is equals to dp dot second +1, or rm q में भी डाल दो, and we are doing that. Fair enough. Now we would see to it वो distance में -1 क्या काम दे रहा है. Fair enough. So first we are initializing the answer as -1. Okay, एंड जो मैंने बताया 5, 10, 15 वाला केस, 5 मिनट्स वाला केस, सो व्हाट आई एम डूइंग इज, वो मैक्सिमम को वी आर ट्रैकिंग दैट. सो वी आर जस्ट ट्रैकिंग व्हाट इज द मैक्सिमम टाइम, एंड देन वी आर ऑल्सो ट्रैकिंग दैट सपोज व्हाट इज दिस, ai is equals to j. So this means if a fresh orange is present and the distance after all doing all this is -1. सपोज वो डिस्टेंस -1 ही रह गया, वो कभी अपडेट ही नहीं हो पाया, तो दैट मीन्स वो ऑरेंज में वो ऑरेंज को वो रॉटन कोई भी रॉटन ऑरेंज पहुंच नहीं सकता है. दिस इज द केस. सो व्हेन दिस इज द केस, सो ऑल रॉटन ऑरेंजेस विच इज प्रेजेंट, सारे ऑरेंजेस तो सड़ नहीं पाएंगे. दैट वुड बी द केस. सो वी आर मार्किंग एज boolean as OK1. So if all oranges can't be rotten, we are making answer as -1. At the end, if it is having an answer, whatever be the case, we are returning it. Okay. So still this code is complete, but okay, there is only one person right now. So I would still wait for that one person to see if he has any doubts that is still persisting. After that, I would be turning this session off. If you have any queries, let me know. I would explain you. If you want more questions on multi-source BFS, or you have something to ask, you can ask me in the comment section. But for the links of the question, you need to text me on LinkedIn. My username is Siddharth Hazra. So that's it for today. Thank you and have a nice day. This is me, Siddharth Hazra, signing off. And by the way, on a small note, my PC was facing some issues at the last moment when I was about to stream on the webcam I am using. So that's why today my webcam was not turned on. But from the next stream which I would do, my webcam, I would ensure that it would be turned on. Thank you. Have a nice day.